Good morning students. This is a class for maximization in assignment problem. Last class we have completed up to Hungarian method. That is how the solution can be done in an assignment problem. So here the question is given below is a matrix showing the profit for different jobs done through different machines. Find an assignment program which will maximize the total profit. So that's the question. Now let's write the question. Write the matrix. I'll write 4 rows and 4 columns are there. That is 4 rows and 4 columns. 2, 3, 4. 4 rows are there and 4 columns are there. Now the row name is J1. There is a job. J1, J2, J3 and J4. J1, J2, J3 and J4. And these are the machines M1, M2, M3 and M4. So there's a matrix. Now the values are 51, 53, 54, 50, 47, 50, 48, 50, 49, 50, 60, 61, 63, 64, 60, 61. That is the values are 51, 53, 54, 50, 47, 50, 48, 50, 49, 50, 60, 61, 63, 64, 60, 61. So that is the value of the matrix. Now find the maximum value from this. Find the maximum value from this. So that is how the maximization problem is being done. The maximum value of the matrix is, maximum value is 64. Consider the whole values. The maximum value is 64. Now subtract each value of the matrix from 64. So that is how the maximization problem is to be done. That is, subtract each matrix value, each entry from 64. Now you get, again, 4 rows are there and 4 columns are there. 4 columns are there. So the first, this is J1, J2, J3, J4, M1, M2, M3 and M4. So while subtracting 64, 51 from 64 you will get 13, 53 from 64 you will get 11, 54 from 64 you will get 10 and 14. Alright, 64 minus 47, 17, 50 minus 64 minus 50, that is 14, 16, 14. Come to the next row, 15, 14, 4, 3, and here 64 minus 63, that is 1, 0, 4, 3. So now this matrix you got. After subtracting the maximum value of the matrix from each entry, you got this matrix. Now find the row minimum. Now do how we have done in the case of assignment problem, that is Hungarian method. Any method, that is same way you have to do. That is row minimum. Here it is 10, here it is 14, 3 and 0. Now what we have to do is, we have to subtract each value from the row minimum value and you will get the matrix 4 rows and 4 columns, 2, 3, 4 columns, and the values will be, that is 13 minus 10, 11 minus 10, 10 minus 10, 14 minus 10. Same way 17 minus 14, 8, 14 minus 14, 16 minus 14, 14 minus 14. So you will get the matrix as 3, 1, 0, 4, 3, 0, 2, 0, 2, 12, 11, 1, 0, 1, 0, 4, 3. So this matrix you got after subtracting row minimum from each value. Now you find column minimum. So column minimum of the first column is 1, 0, 0, 0. So as we know, when 0 is subtracted, nothing will happen. For others, it will be 2, 2, 11, 0. We are subtracting each value from the column minimum value. So 2 is 2, 11, 0. And the next it is same value 1, 0, 11, 0, 0, 2, 1, 4. And the last one is 4, 0, 0, 3. Now this matrix you got. After doing the finding the row minimum subtraction, column minimum subtraction, you got this value. Now you go for row scanning. Row scanning, check the first row, only 1, 0, mark it, cut the column. Now second row, 2 zeros are there, so leave it. Next again 1, 0, mark it, cut the column. Then 2 zeros, leave it. Now come for the column scanning, 1, 0, mark it and cut the particular row. So you got this. And next here it is 1, 0 only, so mark it and cut the corresponding column. Now see, all the zeros have been marked, squared. Now check the number of marked zeros, 1, 2, 3, 4. 4. And that is equal to number of rows. Number of rows is also 4. So 4 is equal to 4. That means the problem is somewhat okay. Now you find the optimal solution. The sources are 1, 2, 3, 4. That is job 1, job 2, job 3 and job 4. That's the sources. The relation is, this is machine 1, machine 2, machine 3, machine 4. So the first is from job 1 to machine 3. So you have to write job 1, machine 3. Job 2 to machine 2. So job 2, machine 2. Job 3 to machine 4. So job 3, machine 4. Job 4 to machine 1. So you got this. Job 1 to M3, machine 3. Job 2 to machine 2. Job 3 to machine 4. Job 4 to machine 1. Now we have to take the values. We have to take the original matrix values. First in question which matrix we have got, that values we have to substitute here. So job 1 to matrix machine 3. Job 1 to machine 3. It is 54, right? So write here 54. Job 2 to machine 2. Job 2 to machine 2. That is 50. So write here 50. Then job 3 to machine 4. Job 3 to machine 4 is 61. So write here 61. And job 4 to machine 1. Job 4 to machine 1 is 63. So write here 63. Adding, you will get 228. 228. So that is the answer. 228. That's the total profit. The question is to find an assignment program which will maximize the total profit. So the answer is total profit, that is 228 rupees. So that is how maximization problem is done in an assignment method. So the thing is that first take the maximum value from the matrix, subtract each entry from the maximum value, you will get a matrix. Then as usual, go for the row scanning, go for the row minimum, subtract it, go for the column minimum, subtract it, then go for row scanning and then go for column scanning. Check whether the marked zeros are equal to the number of rows, and if they are equal, come to the conclusion, or go for the Hungarian method and do. So that is how maximization is done in assignment problem. So next class will come with another topic. Thank you, dear students.